This is Josh White with JW Math Tutoring. In this video, I'm going to go through 10 problems from the August 2025 Digital SAT Math Test. So let's go ahead and take a look.
But life is a dream the calculus could never predict.
Before I begin going through this third problem set from the August 2025 Digital SAT Math exam, I just want to mention a couple things that I do at the start of each of these official test question videos. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, you have any questions or comments or alternate solution methods, or if you find any errors, hopefully there won't be any, please leave them in the comments below. Third, there'll be a link to the PDF file with these problems, both in the description of the video and in the pinned comment of the video. And fourth, so I've collected these mainly from Reddit, but also a couple from Discord as well. I've tried to recreate them to make them, as realistic as possible. But it's likely that if you had one of these questions on the test that you took in August, the wording might be slightly different. Okay, so just keep in mind I've tried to recreate them as best as possible, but they might not match exactly a question that you had or you saw on your exam. Related to that, these questions, most of them are going to be free response, but it's possible that on an exam they might have been multiple choice. So there could be other solution methods available if a question is multiple choice that I wouldn't show because I'm doing that as if it's a free response, when we have to type the answer in. So please do keep that in mind as well. Oh, and lastly, if you haven't done so already, do check out the videos for part 1 and part 2. And once it's posted, part 4 as well. We should have 40 total problems. All right, so let's go ahead and get started here with question number 1. Here you have a wheel. I mean, it could be anything really. It could be car, whatever. And it moves. It starts at rest. It increases its speed to some number after some period of time. Then, for a second period of time, in my example, it increases its speed. Technically, it could have decreased its speed. It doesn't, whatever, it doesn't matter. But what you're comparing is basically the average rate of change of the speed over both of the intervals and essentially subtracting them. And it says positive difference here because we want to take the larger one minus the smaller one, regardless of which one happens first versus second. So over interval 1. All right. Basically, think of this as like points. So it starts at rest. So the time is 0, its speed is 0. And then after 5 seconds, its speed is 12. So the average rate of change is just going to be 12 minus 0 over 5 minus 0. It's 12 over 5, or you could make it a 2.4 as a decimal. Now for interval 2, it's starting, basically, it switches interval 2 at time is 5, at t equal 5, and when its speed is 12 meters per second. And then the ending speed that it reaches is 23, so that's going to be the y value, and this happens after 3 more seconds. Therefore, it's not 3 here. Remember, the time will be 8, right? Because it's starting at 5. It rolls down the hill for 3 seconds, so that means at time t equal 8. Again, the speed reaches 23. So now we can do the same calculation. Average rate of change is basically like a slope calculation. 23 minus 12 over 8 minus 5. And here on the bottom is where you could technically just plug in a 3 because it tells you that the total time, change over the second interval is 3 seconds. So we get 11 over 3. That's also 3.6 repeating. So now you just have to subtract these two values, okay? And the second one is the larger one. So we'll do that one first. So let's just go to Desmos. And let's just do 11 thirds minus 12 fifths. We get 1.266. If you want to convert to a fraction, it is 19 over 15. So correct answers to this problem would be 19 over 15, 1.266, or 1.267. All three of those for these values that I've chosen would be considered correct. All right, let's look at the next problem where we have a right triangular pyramid. So that means we got a triangular base. Let's see if I can draw this correctly. Probably not. And then the height coming down here, perpendicular. All right, we have, so this triangular pyramid has 4 triangular faces. Might not be easy to see from my poorly drawn diagram, but um, this question looks difficult, looks complicated, but it actually isn't, because the formula for volume of pyramid is just 1/3 base times height, where b is the area of the base. All right, so in this case, the area of the base, well, that's just this triangle right here. We know the volume, we can plug that in. Area of the base, that's what we're going to solve for, and we know the height. 3 goes into 15 5 times, so the area of the base is just going to be 25. Again, this equation, you could just take it and type it into Desmos if you wanted to. 125 1/3 times area of the base times 5. Not 5, sorry, 15. 5 is what you get after you cancel the 3 out with the 15. Okay, so there we get area of the base equals 25. So that means the area of this triangular face is 25, and the other triangular faces, of which there are 3, vertical ones, will also be 25. So we need to take 25 times 4 to get the total surface area being 100. And so that's the answer to this question. For the total surface area, no more work is needed. All right, let's move on to question number 3. I'm going to have to zoom out to fit this whole thing on here. Okay, so basically, I believe for this question you were given a graph. I don't know if you were given the actual like curve or you were just given random points, but you were given the graph of a function, I believe it was an exponential function, and then you're told a new function is made by multiplying the y coordinate of every point on the original function by 20. All right, so in this example, first of all, this is an exponential function, and notice it's decreasing as it goes from left to right. So that means that, think about an exponential function, it's like a times b to the x. That means the b value must be between 0 and 1. Okay, if it was greater than 1, then it would be increasing as it went up to the right, basically like that. So that means process of elimination, I could eliminate, these two right away. But even if that wasn't the case, really we're looking here for everything being multiplied by 20. So what you would want to do is you'd want to look for a point that's basically like right on an integer value. So it looks like it crosses here at 16. So we could use that. Or we could use, let's see, something that's a pretty good estimate. I mean, I guess you could use right here, 1, 2, 3. It looks like it's at 3, comma, roughly 0.5. And then you're going to multiply these y values by 20. So that's going to be 0, comma, 320. And this one's going to be 3, comma, looks like it should be 3, comma, 10. 0.5 times 20, half of 20 is 10. And then you can go to the answer choices and just graph them or evaluate them, however you want to do it, and see, do they go through those points? So for example, does the first one go through 0, 320? No. It crosses right here at 0, 20. All right, so that's obviously not correct. And then if we look at the second one, okay, so 0, 320 is going to be, you'd have to zoom out like way up here and try to find it. And, oh, yeah, there it is. It goes through 0, 320. But let's say we didn't want to check that. Let's say we wanted to check 3, comma, 10. So let me just go back here. X equals 3. So where's the point? So notice it's not exactly 310, but it's fairly close. And the reason is because this is just an estimate. Like, I estimated this to be 0.5, but it's obviously not 0.5. It's something a little higher than that, like 0.6 something or whatever. So 3, comma 10 is just a reasonable estimate. And because when you check the other answer choices, none of them for the x value of 3 are going to have a value that is anywhere, say, near 10. You know what I mean? They're all going to be significantly larger or significantly smaller. So this is how I would approach this question, again, by like finding a point or points, multiplying the y-coordinate by 20, and then graphing out the answers and evaluating them and seeing which one matches, which one goes through that point or points. All right, so let's look at the next one, number 4. And let me just zoom in back to our original size here. Okay, this person is depositing money into her bank account, basically X dollars once a month and Y dollars twice a month, and the total is 4,400. Which equation represents this situation? So I will tell you the correct answer is going to be letter D. Here's the kind of the theory or the way to reason this. Okay, she puts in X dollars per month, right? Once a month, 1 X dollars per month. Okay, and then over a year, how much would she have contributed? Well, X dollars per month times 12 months. Then she puts in Y dollars twice a month. Or, really the way to think about this is she puts in 2Y dollars per 1 month, right? Because she does it twice. So the total at the end of the month is 2 times Y. And again, how do you figure out the total she would contribute from these monthly deposits? Well, we'd multiply this again by 12, because there are 12 months in the year. So she's putting in 2Y dollars per month times 12 months. So notice the months cancel out, you get 12 times X. The months cancel out, you get 12 times 2Y, which is 24Y, and that's equal to the total amount of money deposited, which is the 4,400. Now you could pick numbers, I guess, for X and Y and like figure out like you'd have to like basically you'd have to pick them such that they would work out to exactly equal $4,400. But I think that's way more complicated than this needs to be. It's much simpler, much easier to just understand, how to set up the linear function by interpreting the text here. All right, let's look at the top of the next page. Question number 5. You are given a table with the results of 4 different surveys. You're given the mean of each survey. You're given the margin of error of each survey. And wants to know which had the largest sample size. Now, one thing just to mention is we're assuming that the methods for all of these surveys are the same. Okay, so whatever random sampling or how they're administering the survey, we're assuming it's done the same for the 9th grade versus 10th versus 11th versus 12th. Okay, so you have to assume that in order to draw a conclusion about the sample size from this data that we're given. Basically, all we need to know really is the margin of error value, because there's an inverse relationship between margin of error and sample size. So in other words, large sample size equals small margin of error. And then the opposite is also true. You have a very small sample size, that's when you have a large margin of error. So we want the largest sample size, so we want this. So we want the smallest margin of error. So which of these is the smallest? Well, it's this one right here. So the answer is letter D, 12th grade. 12th grade survey had the largest sample size because it had the smallest margin of error. All right, let's look next at question number 6. So in this one, you're told that basically you have the price of some item. I chose a concert ticket. And it initially was like tried to be sold at some dollar amount, and none were sold, at that dollar amount. Then, they started decreasing the price by whatever, some amount. I chose $1.50. And as you do that, the number of things, in this case tickets, increases by 1. So for every $1.50 drop, the number of tickets increases by 1. Again, probably not a realistic scenario for the numbers I chose. For concert tickets, this might be like increases by 1,000 or something. But just worry about the actual methodology we use to set up and solve the problem, not how realistic it might be in real life. Okay, they give you the total revenue, and they want to find out how many tickets were sold. So First of all, revenue is going to be equal to the price of a ticket times number of tickets sold. Okay, so we have to come up with an equation now to solve. We know the revenue, 38 times 30, 1348 times 50. Okay, the number of tickets sold is going to be x. That's what we're going to end up solving for. The price, however, basically it's a linear function. And essentially what's happening is you start at 90 and then you subtract 1.5 or 1.50, if you want to use that, x. Because essentially what's happening is like this change, like the tickets sold increasing by 1, tickets sold increases by 1 for every decrease by 150. So that essentially becomes like your slope in your formula. The minus 150 over 1, plus 1 on the bottom here, minus 150 on the top. So that like this minus 150 over 1, this is like number of dollars, and this is, say, number of tickets on the bottom, and you multiply that by x, which is a number of tickets, and notice that leaves you with a number of dollars overall, which matches the $90, that the price that we're starting at. So this whole thing will be in dollars, which represents the price. Okay, so basically, now that you have this set up, you can solve this by hand if you want to. I instead would just go to Desmos. So what I would do is, let's first clear this. There's multiple ways you could do this. You could just type it. Get that out of the way, and then we can look for some vertical lines. Those are the solutions. So notice here there are actually two solutions because this is a quadratic. So there's actually two different number of tickets sold that come up as correct. You have 29 and 31. So either there's two correct answers to this problem, or the other possibility is that this was a multiple choice problem and only one of these was listed along with three other incorrect answers. So either way, this is the method, this is the method that you use to solve it. This is the equation you set up. Basically, it's like the starting price minus the, whatever the decrease in price per ticket sold is, whatever that dollar amount is, times X, which is the number of tickets sold. That's the price. And then multiplied just by another X for the number of tickets sold, because the price of a ticket times the number of tickets, that's how you get your total revenue. All right, let's look at the next question, number 7. So in this one, you have a circle. Its center is here at 3, 8. You have a line L, which is tangent to it, and it's at a negative 5. So it could be here or it could be here, but because we know that the slope is a positive 5/4, we know it has to be this one, right? Because the tangent line has to be going up like that for a positive slope. And we know this point is a negative 5. So now basically what's going on is we know that the slope of this line is 5/4. Therefore, if I draw a line, or specifically a line segment, from the center of the circle to the point of tangency, it will be perpendicular to the tangent line, which means this slope over here will be the opposite reciprocal of the tangent line slope. So it will be negative 4/5. So essentially what you have is the slope of this radius of the circle, negative 4/5, equals, and now you could do 8 minus negative 5 over 3 minus a. Now at this point, I would just go to Desmos and I would just type the whole thing in. So let's see here, negative 4/5 tilde 8 minus negative 5, 3 minus a. What do we get for a? So it looks like we get 19.25, or if we want to put it in fraction form, 77 over 4. 19.25, or again, 77 over 4. So that would be the correct answer. Now in Desmos, you can plot these out just to confirm that, like, yes, everything looks visually correct. So, for example, you take the point 38, and then you take the point a comma negative 5, and actually, no, what I would do, actually, let's do this instead. I'll show you, like, this is, I guess, how you could do this is how you could do the work in Desmos if you wanted to. You could say, all right, I have these 2 points. I want a linear regression of a line between them, and I know the slope has to be negative 4/5. Okay, so there's the line going through 3, 8, and a negative 5. Now, the problem is, um, if you don't know this in Desmos already, if you don't know the a, I'm just doing this to check, essentially. So then what you would check is you would say, okay, I want a line going through the a negative 5 point, and I want it to have a slope of positive 5/4. This should be y2, x2 plus b. Okay, so now here's the line which is tangent to the circle, technically, and yes, these lines do appear to be perpendicular. Okay, so now with all that being said, let's say you want to do all the entirety of the work in Desmos. All right, so here's how I would approach that. First, you would have to figure out that the slope of the line is the slope of the radius going from the center to this a negative 5 point is negative 4/5. Okay, so then I would enter in my 2 points, 3 comma a. Those are the two x coordinates. I'm going to enter them in a list. I'll explain why in a second. And then I would enter 8 comma negative 5. Those are my two y coordinates. And then I would do a regression of y1 tilde. Now I have to know that the slope is negative 4/5 x1 plus b. All right, yep, and right here. This is how you would do it all in one step. Again, you do have to figure out or realize first that the slope of the line, which goes from the center of the circle to this a negative 5 point of tangency, is negative 4/5. So that you have to know, but everything else you can just enter the points in. And the reason I have to enter them in a list is because of the a, because I'm using a constant. If you try to enter them in a table, it will not work properly. I don't think it will find the value of a correctly if we enter them in a table. But if you enter them in a list like this, then obviously it'll find the value of b, the y-intercept, but we don't care about that. But it will also, notice down here, it'll also find the value of a as well. So you have to enter them in separate lists, all the x coordinates in one list, all the y coordinates in another list. And if you want more information about that, check out my ultimate Desmos guide to digital SAT math. I will put a thumbnail on the screen showing you which specific part of the playlist this topic is covered in. All right, let's look at question number 8. Now, here we have a um, basically repeat problem. This one has been seen multiple times before, but it came again, so we'll go over it again. And first, I will show you how you would do this by hand. Then I'll show you how you could do it entirely in Desmos. And in Desmos, it's going to be the same process with using lists, just like I did. So just plug in the points. A to the c minus b equals 4. A to the 2c minus b equals 114. Now, we want to find the value of b. So I'm going to solve this for a to the c and get a to the c equals b plus 4. Then I'm going to plug that in here. So this is 2c, right? So you could also rewrite this as a to the c squared. So a to the c is b plus 4 and then squared minus b equals 114. Now at this point, you could just go straight to Desmos and solve it, but if you wanted to write out all the work, it just becomes b squared plus 7b minus 98 equals 0. And so again, if you go back just to the original step, and it's going to factor. It's going to be b plus 14, b minus 7, but because you have Desmos, you don't need to spend the time doing that. You can just type the whole thing in. Oh, that's right, we can't use b, so let's make it x1. Not x1, we're not doing regression, just make it x. What am I doing here? Okay, now let's look for some vertical lines. Okay, so notice we have a negative 14 and we have a positive 7. So those are the two possible values for x, or really for b. So what's our correct answer? Well, it's just going to be right here, b equals 7. Now, let's see how we could do this entirely in Desmos, again, using lists. So for my x values, I'm going to enter in this c comma 2c, my 2x coordinates. Y values, I am going to enter in the two y values, 4 comma 114. And then I'm just going to do a regression, y1 tilde a to the x1 minus b. All right, what's the value of b? Well, right here it is 7. So that is one of the answer choices. Therefore, that just confirms that's the correct answer. Again, this is how you can do the entire problem in Desmos. All right, next up, number 9. This is another repeat question. This is a sum of solutions problem. First, I will show you how to do it by hand, and then after that, I will show you how to do the entire thing again in Desmos. So, if I was going to solve this by hand, I would I would move over the two terms on the right, x minus k, hold on, let me fix this, x minus k minus 5a. So everything's equal to 0. Then I factor out a common factor of x minus k. That leaves me with x minus k, and then in the second one, this is gone, so now it's a negative sign distributed, minus k, negative and negative, positive, plus 5a equals 0. So now I know that one solution is k. This becomes x minus 2k plus 5a. Again, if you set it equal to 0, you get x equals 2k minus 5a. All right, so now I can sum these up, k plus 2k minus 5a, and set them equal to 3k plus 24. K plus 2k is 3k. Notice the 3k's will cancel out. Negative 5a equals 24. Divide by negative 5. A equals 24 over negative 5, or negative 4.8. So either of these could be entered as your answer. So that is the correct answer for A. But now let's see how we could do this entire thing in Desmos. So then, this is solving a sum or product of roots problem. The technique is the same. Check out the thumbnail on the screen, which will show you which specific part in my Ultimate Desmos Guide to Digital SAT Math covers this topic. So I'm going to start it the same way, meaning I'm going to subtract over the parentheses from the right. Since I'm going to do regression, I need to do x1, so I'll fix that. Now, what I'm going to do is I'm going to do regression to, this is a quadratic, so I'm going to do regression to basically its intercept or factored form. And b and c here are going to represent the two roots or solutions or zeros. Now, we know that the sum of the solutions, so in other words, b plus c, equals 3k plus 24. Except when you do this, it has to be, this equation, I call it a constraint equation, has to be solved for just one letter. So I have to subtract the c over to the right. Or you could subtract the b over and make it c equals, that part doesn't matter. Now, I need to put in my list for x1 to tell Desmos to treat x1 as a variable. I like negative 2, 0, and 2 because I get a positive, a negative, and 0. That really helps with these quadratic type regressions. And then notice it's now honed in on a equaling negative 4.8 or negative 24 over 5, the exact same answer we got when I did it by hand. So this is how you could solve the entire thing in Desmos. All right, next, let's look at the last problem here, question number 10, factoring problem. So this one is technically going to be a difference of squares, but first you have to group the first three terms here as a trinomial and basically factor them as a perfect square. It's going to factor as like x squared x squared, and then it's basically going to be 3a and 3a. And they're both going to be positive. So that means you have x squared plus 3a squared minus 81. But now, notice 81 can be rewritten as 9 squared. So now you can do x squared plus 3a plus 9, x squared plus 3a minus 9. So which of these do we see in the answers? So it looks like, yeah, it looks like it's going to be letter A here. X squared plus 3a minus 9. The others are all, incorrect. Second one has the wrong signs on it. It's got 2 minus instead of 2 plus or 1 plus and 1 minus. All right, one alternate approach you could take to do this in Desmos is, let me just erase these temporarily so we can see all of them clearly. You can type the original expression plus 9a squared. Okay. Now you have to add a value for a. I just chose to add 2. Then what you would do is you would type each of the answer choices, and the one that is a factor, the one expression that factors, is basically going to, let me just set this to y equals. The one that's a factor is the only one that is going to basically intersect the x-axis at the same points, or have the same x-intercepts, the same zeros, the same roots. So like notice this one does not, this one does not, this one does not. Okay? And the reason for that is because basically, if you think about factoring, right? If something is a factor of something, so you have like x minus 6, right? Say that's a factor. That means that the graph crosses or touches or crosses at x equals 6. Basically like the opposite value of that, right? So the same thing is going to be true for these two things. Basically, like you take the original expression and you factor these. You take the original expression and you factor it down, right? So you're going to get essentially if like you would plug in the a value for 2 and then you would go ahead and solve this, you're going to get x equals some number from each of these. And technically, it looks like it's going to be a plus or minus because it's a quadratic for each of these factors. So whatever that number is, like you're going to get the same number for the factor itself. Meaning you take, like, because basically you take each of these factors and say you go ahead and try to solve it. And you could get, I mean, really you're only going to get 2 answers. One of them is going to be complex, so that's not going to matter, ignore it. But the point is, you're getting, if you set this equal to 0, you get, say, 2 x-intercept values, okay? 2 points where it crosses the x-axis. So when you go look at the factors, you're going to get the same values. You know what I'm saying? Like, in other words, you set this equal to 0, this is the same as this. So we get the same x-intercepts or same values. However, that's not going to be true for the other things necessarily because they're not factors. So the point is, same x-intercept like from a factor while solving it is going to give the same x-intercept from just the factor itself while graphing it. In other words, that's why they have to match. That's why we're looking for, things crossing at the same values here. So this is just the Desmos approach you could take, but if you know how to factor this using a difference of squares, I don't know that it necessarily, I guess, saves you that much time if you don't, fully understand it. All right. So with that being said, I hope you enjoyed this third August 2025 SAT official exam problem video. If you did, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Again, if you have any questions or comments or alternate solution methods or corrections, please leave them in the comments section below. I always do read the comments. If you haven't watched videos 1 and 2 from this August 2025 series. Please check those out as well. And then once it's posted, of course, part 4. And lastly, if you're looking to improve your knowledge of Desmos, please check out my Ultimate Desmos Guide to Digital SAT Math. It is over 5.5 hours of tips and tricks and instruction, and there's also 65 practice problems to help you ace the math section of the digital SAT exam.